Lesson 10. Biot-Savart Law, Ampere's Law. Section 10.1. Biot-Savart Law. A current I flows through a line conductor L. This current generates a magnetic field around it. The right-hand screw rule is a visual mnemonic for retaining and retrieving the relationship between I and H. The thumb points in the direction of current and other fingers indicate the direction of magnetic field. Let's consider a differential current IDL. At point P, at a distance r1, let's denote the generated differential magnetic field strength as dH1. According to the Biot-Savart law, dH1 is given by this equation, where AR1 is a unit vector directed to point P from the differential current IDL. The numerator is the cross product of the vectors IDL and AR1. Let's review the cross product. Suppose that vectors A and B are on a plane S. The cross product A cross B is perpendicular to both vectors A and B. Thus, it is perpendicular to the plane. The direction of the cross product is in the direction of right-hand screw. The angle theta between the vectors is measured from the first vector A to the second vector B. The magnitude of the cross product is given by this equation. This is another example of a cross product. The angle is also measured from the first vector A to the second vector B, and in this case, the direction of A cross B is downward. Therefore, dH1 is perpendicular to the plane in which both IDL and AR1 lie. The unit of magnetic field strength is Ampere per meter. The magnitude of dH1 is given by this equation. This slide shows the superposition principle for the magnetic field. dH1 is a differential magnetic field strength generated by an element of the line current. dH2 is generated by another differential current. The composite magnetic field strength dH is the vector sum of dH1 and dH2. The magnetic field strength at point P is the line integral of differential strength along L. Exercise 10.1.1. Pause the video, and answer the problem. Find the magnetic field strength H at point P. The answer to exercise 10.1.1. According to Biot-Savart law, the differential magnetic field strength dH is given by this equation, where IdZ is the differential current, and AR is the unit vector from the current element to point P. Then, dH is expressed as a function of the coordinate Z. The total H is obtained by integrating dH along the conductor from negative L to positive L. This is the final answer. Exercise 10.1.2. Pause the video, and answer the problem. Find the magnetic field strength H at point P, when the length of the line conductor is infinite. The answer to exercise 10.1.2. In the extreme, as L in the result of exercise 10.1.1 goes to infinity, H approaches this value asymptotically. The cross indicates that the direction of H is perpendicular to the slide surface you are viewing, and it goes away from you. The cross symbolizes the tail of an arrow. The x-axis in this Cartesian coordinate system comes out toward you. Its direction is denoted by a dot as shown in the bottom left figure. This dot represents an arrowhead. The magnitude of the magnetic field strength, at a distance r from an infinite line current I is, I over 2 pi r. Exercise 10.1.3. Pause the video, and answer the problem. Find the magnetic field strength at point P when a current J uniformly flows over the xz plane. The answer to exercise 10.1.3. According to the result of exercise 10.1.2, the magnitude of dH is given by this equation. Due to the symmetry of current flow along the x-axis, the y components of dH are cancelled out. The x component is expressed by this equation, and needs to be integrated. We can perform the integration as shown in this equation. This integration by substitution is a common practice for this function. With this change of variable, the integration becomes possible. And this is the answer. The magnetic field strength due to an infinite plane current is independent of coordinates. Exercise 10.1.4. This is your homework. Pause the video, and answer the problem. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.